part of the feedback that I got from class today is that we're a little shaky on trig graphs, which is totally fine because last year was cut off short. And so what I thought I would do is let's just start all the way back in geometry, where you were taught that these trig functions were just ratios of sides of right triangles that depended on one of the angles in a right triangle that we're going to call theta, but not the right angle. You can't focus on the right angle. It's one of these two acute angles within a right triangle. So if we call this theta, you were taught that if you went straight across from theta, that was the opposite side of your angle, and that the largest side of the right triangle was the hypotenuse, and then the remaining side right next to your angle theta was your adjacent side. And then your teacher at the time probably defined sine, cosine, and tangent using SOHCAHTOA. Where sine of theta is the ratio of the opposite side over the hypotenuse, cosine's the adjacent over the hypotenuse, tangent's the opposite over the adjacent. And that's great. Then you got to algebra 2, where trigonometry was more defined by within the coordinate plane. So everywhere in the coordinate plane has x and y coordinates. And so how does this connect to what you learned in geometry? Well, basically we use this idea of a unit circle, which is just a circle where the center is at 0, 0 on the xy axes, and the radius of that circle is 1 unit. So if I think about any point on the unit circle, and I think about drawing a straight line, which is a radius of my circle, and by the definition of the unit circle, the radius is 1. So that's kind of cool. And then if you think about, well, if you were to graph this point, you'd go over the same amount as whatever the x-coordinate is, and then you'd go up by the same amount as whatever the y-coordinate is. So this distance would be x, and this distance will be y. And what you've created now is a right triangle. So now, where are we going with this? If I just think about sine and cosine and make a connection to geometry, I would have that the sine, and here's my theta, of theta is opposite over hypotenuse. Well, what's my opposite? My opposite side in this triangle is y, and my hypotenuse is 1. Well, anything divided by 1 is just itself, so the definition of sine theta is just y. That's kind of interesting. And then if we think about the cosine of theta, well, that's just my adjacent side in my right to my angle in my right triangle, which is x, over my hypotenuse, which is 1. So the definition of cosine is just x. So here we go. Is if I want to make a sine graph, I just need to figure out the y-coordinate on my unit circle as I go around 360 degrees. So I'm just going to label some angles. We know that in standard position, this angle is 0 degrees. Then I go 90 degrees, 180 degrees. I'm just going around my circle like this. 270 degrees, and then 0 and 360 land in the same spot. If I were to just redo that, so let me back this up, in radians, I get 0. Remember, in radians, if you want to just remember, is that pi radians is equivalent to 180 degrees. So 90 is equivalent to half of a pi, or pi over 2. Pi, 3 pi over 2, and 0 and 2 pi are at the same spot. These are my benchmark angles because if I think about a unit circle, if I were to think about this point on the circle, well, I would just go over 1 unit, which would take me to the point 1, 0. If I were to go up 1 unit, I'm at 0, 1. If I go left 1 unit, I'm at -1, 0. And if I go down 1 unit, I'm at 0, -1. So all you really, I'm giving you way too much information, but all you really need to know how to do is graph a cycle of sine and a cycle of cosine. So I start with my benchmark angles. And if you just recall, the sine is just the y coordinate at each one of these angles. So if I think about the y coordinates, when the angle is 0, my y coordinate is 0. So I graph the point 0, 0. When my angle is pi over 2, my y coordinate is 1. So I'm going to graph the point pi over 2, 1. I'll just say that's 1. And I'll label that. On my y-axis, that's 1. And then I'll go down here to -1. Let's see. The y coordinate at pi, if I go over to pi, my y coordinate is 0. So I'm going to graph that. At pi, I'm going to graph 0. At 3 pi over 2, I'm at -1. So that's where this is coming from. It's just the definition. And then at 2 pi, which was the same as 0, same location, I'm back to 0. I'm going to connect that with a nice smooth curve. And there's my cycle of sine. Some things just, if you're doing this real quick, just know you got to graph a total of 5 points per cycle. And that sine starts at the midline. Now, if we go through and kind of do the same process for the cosine, I'm just going to do the same exact thing, except I'm going to be graphing the x-coordinate as we go through a full rotation. So I'm just going to graph the same angles because those are the easiest to determine the x and y coordinates of. And now I'm just going to go through, I'm going to figure out what the x coordinate is. So at 0, I'm at 1. Oh, and I got to label that. So 0 starts at 1. Pi over 2, the x coordinate is 0. At pi, the x coordinate is -1. So -1 for pi. At 3 pi over 2, the x coordinate is 0. And at 2 pi, the x coordinate is 1. Okay, extra credit opportunity. Figure out what a cycle of tangent theta would be and graph it. But this is just one cycle of cosine. Notice it's still 5 points that you need to graph per cycle. And a difference is that cosine, if it's just a regular cosine function, starts at a maximum. I mean, another way I remember it is sine, and I mean, it's not perfect, but it kind of looks like a sideways S. Cosine, if you tilt your head a little bit, sort of looks like a sideways C. If that helps you, use it. If not, forget it. But I hope that this was a helpful video for how to graph a cycle of sine and cosine, and also where they come from and how they connect to geometry.